In 8.2, we start to combine functions through multiplication and division. So in this video, I'm going to do more of a lesson, and then the next 8.2 video, I'm going to do all examples. All right, so let's start off with the warm-up. What I have here are two functions. You got your f at x and your g at x. One is a quadratic and one is a linear. I'm going to create two new functions, one through multiplication of the original functions, and then one through the division of the original functions. Okay, so why don't we start off with h at x, and we're going to do this algebraically. Here's your f at x, I got that from right there. And then I'm going to multiply my g at x, which is right here. Okay, so we're going to expand and simplify. It's just as easy as that. Take this x and multiply it into your bracket, so that's the expanding part. And simplifying, well, doesn't really look like any of them are like terms, so I can't really put them together. This is our final answer then, okay? And we should kind of expect something like that, because if we were multiplying a degree 2 quadratic, right, and a degree 1, which was a linear, well, wouldn't that make a degree 3, which is a cubic? All right, so let's take a look at your k at x now. I'm going to divide the f at x over the g at x. Now, if you can simplify further, do it. So this one could be divided by x, and this could also be divided by x, but this one can't be divided by x. So instead of simplifying further, I'm just going to leave it as is. So this is as far as I'm going to go. I mean, it's a rational function, and that's your answer for k at x. Okay, so the algebra, it's not too difficult. The graphing is always a little bit more difficult. So here's a slide that shows different ways that you can write how to combine these functions through multiplication and division. In the warm-up, we wrote it like this, where in the multiplication you had f at x times g at x. When we combine them, you can also see it written as f times g at x. Okay, and just like in the division, you can either see it separated as f divided by g, or you can see them put together as f divided by g of x. Now, I need you to note that there is a restriction now because you have some sort of a quotient. I mean, this was the rational function in, say, the warm-up, where you did have some sort of a denominator function. Okay, so this guy right here is your denominator. If this was ever 0, you're going to have an undefined answer. Okay, so we need to note that the restriction will be when this is equal to 0, you're going to have some sort of probably like an asymptote. All right, so I'm going to show you some examples of that later on. All right, so just like in 8.1 when we were adding and subtracting functions, when we're multiplying and dividing functions, we actually can figure out the answers algebraically or graphically. So algebraically, I mean, we saw that in the warm-up where we just multiply or divide the functions. We're going to simplify if we can, and if we can't, we just leave our answer as is. Graphically is very similar to when we added and subtracted functions in 8.1. So you need to make sure that your domain has similar x values. And then what you're going to do is you're going to take your y values and you're going to multiply or divide them depending on what the question is asking about. Okay, so let's just talk about products of functions first. So when we're multiplying two functions together, we definitely need both of the functions to overlap in terms of their domain. In terms of their range, I mean, we could try to predict what the range will look like, but it's a lot easier when you actually multiply both of your functions together. So for instance, like let's just say one function was a cubic, one function was linear. Both of those functions have ranges that go on forever. So you would expect that if you put those two together, your range would go on forever. But actually, when you multiply these two together, you get x to the power 4. That looks more like a parabola. So then you do have some sort of restricted range. So you see, in terms of multiplication, the range is not always very evident until you actually, figure out what the resulting function is. This is just extra stuff. I mean, if you have two functions that are both even and you multiply them together, you're going to get an even function. If you have two odds that multiply together, just multiply together, sorry, you can get an even function as well. And when you have one of each, so one odd, one even, if you multiply them together, you're going to get an odd function. Okay, let's talk about division for a second. So in terms of division, you can have an overlapping domain, except there are certain values when your denominator is going to be a 0. So I mean, when you have parts of that domain where the denominator is going to be a 0, that's going to give you some sort of a problem, and that's probably where your asymptote is going to exist. Okay. In terms of restrictions, you could again have restrictions depending on probably your denominator. All right, and again, if you have two even functions that are being divided, you're going to get an even function. If you have two odd functions that are being divided, you're still going to get an even function. And just like before, if you have one of each and you end up dividing them, you're going to get an odd function. Okay, so this was a very quick lesson, and why don't you check out the next video for any examples.